Welcome back to the Edison Awards Meet the Innovators Forum. We're glad you're still with us. Please take your seats if you're here locally. If you're at home, you don't have to take a seat if you don't want to at home. You can do whatever you want at home. But here, we'd like you to come back to your seats and listen up here. You know, as we sit here at the beautiful Babcock Ranch facility, we're right on the edge of Florida's wonderful Everglades. It's a rich and diverse natural ecosystem that human beings have been tinkering with for about 100 years now. And they have all kinds of disparate needs that we've been trying to manage for. Flood control is a big part of it, maintaining agriculture in the Everglades agriculture area, and of course, keeping the water clean coming out of the Everglades, allowing the Everglades to do what it does, which is clean out the water. Trying to engineer all that and trying to solve for all those problems is a huge challenge that we're still trying to figure out, frankly, these days. But the big companies that are involved in agriculture in the Everglades are paying much attention to this and trying to come up with sustainable ways to continue to produce all the produce there, the sugar and all the other produce, and yet keep the environment the way we like it. Joining us now to talk about this is a team from U.S. Sugar and the University of Florida. We have Michael Ellis, who is the VP for Strategic and Environmental Affairs for U.S. Sugar. Ryan Duffy is Corporate Communications Director for U.S. Sugar, and Gene McAvoy, who is at the University of Florida. You know, let's talk a little bit for folks, for the uninitiated. Maybe Ryan, you can pick it up. Give us an idea of the history of U.S. Sugar and sugar in general in the Everglades.
Definitely. Well, thank you, Miles. And I wanted to just say thank you to Babcock Ranch for hosting this great event. It's a wonderful opportunity. So U.S. Sugar was actually founded in 1931. And like Thomas Edison, our founder hailed from a cadre of innovators with General Motors. His name was Charles Stewart Mott. And he came down to Florida. He took his industrial know-how of building cars and decided to apply that to farming. So we are a company that has a short rail line. The tracks were laid dating back into the 1930s, and we bring all of our cane into the mill. Where we farm is primarily south of Lake Okeechobee, in between Lake Okeechobee and the Florida Everglades. And because of the history of that region, it's some of the most fertile farmland in the world. We have natural muck soils where you can grow pretty much anything, but primarily we grow sugarcane and vegetables and a lot of other crops in rotation. So I guess to answer your question, Miles, you know, we are farmers at heart, and you know, interesting fact I read earlier today is that Thomas Edison was actually a farmer, so it's fitting we're here talking about sustainable farming. He actually grew some, tried to find a source of rubber in and around Fort Myers, and so, you know, farmers are innovators at heart, and you know, we're thankful to be part of this panel.
Gene, why don't you help us understand what the Everglades agricultural area is?
The Everglades agricultural area is about 750 square miles of muck soil, which is an organic accumulation. It was formed over 10,000 years ago at the southern edge of Lake Okeechobee. It is some of the richest soil in the world. It's the largest contiguous area of muck in the world, and it produces a wide variety of crops, including sugarcane. We've got over 400,000 acres of sugarcane. Largest producer of sweet corn in the United States is in the Everglades agricultural area. Over 1 billion ears of corn are produced there every year. Lettuce, we're second only to California in the production of lettuce. You basically could call the Everglades the winter salad bowl of the United States. 70% of the leafy greens that are sold throughout the eastern part of the United States from November through May are coming from the Everglades agricultural area. Also the largest producer of radishes. Green beans is a huge crop out there, and a variety of other things. Herbs like cilantro, parsley, largest producer of celery in the United States, or the second largest producer of celery, again, in the Everglades agricultural area. So it's a rich area.
So Michael, help us understand why it's such a fertile place.
I think when you look at it, like any delta, and if you look at the flow path through Central Florida, that's a historic delta, and so when the the rainy seasons occurred, it came and overflowed the banks of Lake Okeechobee, depositing very fertile soils. And that's you see that in many places in South Mississippi, the Mississippi River corridor as well. It's a very similar process.
So Ryan, how much food is produced there?
So we produce enough food to feed 180 million Americans in the winter months every year. So a lot of the crops that Gene mentioned, but they're available up and down the East Coast of the United States and in local stores, grocery stores. It all comes from the Everglades agricultural area in the winter.
And how important is it to America's food supply?
I would argue that it's one of the most important farming regions because it's on the eastern coast of the United States. If we lose the ability to farm down here, we actually end up outsourcing a lot of it to other countries. And at no time did we see that, more than during COVID. At the beginning of the pandemic, there's a lack of food in some places in the country. And so our farmers, continued to farm. We never shut down. And continue to grow a lot of the crops that everyone depends on every day.
Michael, tell us about some of the technology you're using to make it more sustainable.
Sure. Well, one thing that we committed to do early on, working with IFAS and other research institutes, is the best management practices program. And what it is, really, we realize as farmers that what's important is keeping our soil, our fertile soil, on our land, and our water on our land for use for the crops. So we do many techniques. Some of the things that you heard in the forum just before about, satellite technology and GPS technology and laser leveling. So we were very precise on our farms. We use technology on our equipment where it's self-driven technology on our actual harvesters. So we can farm more efficiently, more effectively, without minimize our passes. Just as you mow a lawn, if we get out there and mow your yard. You sometimes get out of whack, and what some of these technologies allows us to do is stay on the line, be more efficient, use less fuels, and then in addition to that, we do practices where we do sediment sumps, we control our pumps, we try to control the velocity of our pumps, keep the sediment, keep the soil on our property as best we can.
If I could add to that. In the 1960s, one farmer could feed about 22 people, and today, one farmer can feed 155 people. And I think that shows how innovative farmers have become. And the great equalizer in farming has been technology. What Michael was talking about, we call precision agriculture. It's precise farming methods so that we can grow the most food on our land year after year, and we can provide a safe and affordable supply. Nobody thinks about it. You can order food, whether it's through DoorDash or Amazon, and it comes to your door, and you don't think about where it came from. But ultimately, it came from a farmer, and that's just how efficient we've become.
Michael, what about the water quality issues? If you're farming, you're using chemicals, and if you're using chemicals, that has an impact on water quality.
Sure. I think what we've seen from the farmers in the EAA, since the 90s and the Everglades Forever Act, we've have a commitment, as I said, to be a partner, and that partnership includes giving up property south of our farmland to treat this water as it runs off our property. It was something we're very proud of. The water quality issue in the Everglades, about 95% of it meets the water quality standards that we're supposed to meet at this point in time from the state level. Now, from our farm, we're required through the Everglades Forever Act to reduce the phosphorus load by 25%. So that's the water that enters our property to when it leaves. It's tested when it leaves, and we must reduce our phosphorus level by 25%. Historically, over the past 26 years, I think it's around 58% is what our reduction levels have been. Last year, we reduced the phosphorus by 68%. It's something we're extremely, extremely proud of. Thank you. And so we're committed to being a part of this solution to help the Everglades as much as anyone else, and that's something as farmers we're very proud of.
A subject here that comes up a lot is the concern over red tides, and it's a very complicated subject that involves what people are putting on lawns and all kinds of issues. If you're reducing that much phosphorus, can you do any more, or is that the limits of what's technologically possible?
Well, I think we look for continuous improvement at all times. And we work with IFAS and other universities to improve our farming. our practices to do just that. But the red tide blue-green algae issue is a very complicated issue, as you say. What you have to understand is we're south of Lake Okeechobee. Our water does not go back into Lake Okeechobee. In the discharges that occur on the coast, 30% of the water in a general water year ends up from Lake Okeechobee to the east and the west, roughly, and about 68 to 70% is from the local basins. So the local basins are large contributors to the water quality in the end that ends up into these estuaries.
Gene, why don't you help us understand how the water flows from Lake Okeechobee down through the Everglades?
Historically, the greater Everglades extended all the way to Kissimmee, Orlando area, and 500,000 acres or 5 million acres, excuse me, drained into Lake Okeechobee historically. So water would fall on the peninsula in the summer rainy season. It would flow slowly south in sheet flow, enter Lake Okeechobee. The lake would overflow. It would overflow to the east, west, and primarily to the south. But it would take one drop of water approximately 50 years to move from Kissimmee to Florida Bay. Okay? Now, we've changed that system. You know, in 1855, the state of Florida created the Internal Improvement Fund for the purpose of draining the land. The United States gave in the Swamp and Overflowed Lands Act all the wetlands to every state for the purpose of development. Here in Florida, we have 25 million acres. The state received 20 million acres from the United States government for the purpose of development. And again, that was what people wanted to do in those days. They wanted railways, they wanted to be able to farm, they wanted to be able to live. We had a big problem in those days with malaria and yellow fever, and the only way to control those diseases was to drain land. So there was a tremendous effort made to drain land. And it was done very efficiently. In 1877, the Internal Fund or Improvement Fund actually went bankrupt. They had spent so much money. And to continue the effort, they offered a man named Hamilton Diston half of the land that he would be able to drain. Well, that deal fell through, but he did end up buying 4 million acres for 25 cents an acre. And that's basically how the Everglades agricultural area became established. He did build a canal. That canal was basically built to dredge in Philadelphia. He floated it down the Atlantic around the tip of Florida up and drug it up the Caloosahatchee River. At that time, the Caloosahatchee River did not connect to Lake Okeechobee. There were a series of lakes between LaBelle and the lake. So the lake would overflow. It would go through Lake Bonnet, Lake Hickpatchee, Lake Flirt, and there was a falls at LaBelle, and it formed the Caloosahatchee River. Well, he basically came up the Caloosahatchee River, blew up the falls, dredged a canal through those lakes, and connected Lake Okeechobee to the Caloosahatchee River. At that time, the lake was about 18 to 20 feet above sea level was the stage of the water. His canal dropped that water and opened up tens of thousands of acres in what we now call the Everglades agricultural area. And that was the start of it. Unfortunately, nobody realized at that time when he dug that canal, we were in the height of about what nowadays you would call a 100-year drought. So a lot of the drainage was not so much from his canal, but it's due to the fact it wasn't raining that much. A couple years later, it started to rain, and that area flooded again. And Governor Broward at that time called in the Army Corps to look at that, and they realized that it wasn't going to take one canal, it was going to take at least 5 canals. And so 5 canals were eventually built. You have the Caloosahatchee, called the C-43 Canal now, St. Lucie River. You have the Miami Canal, which goes down to Miami, the North New River Canal, which goes down to Fort Lauderdale, and the Hillsborough Canal. So it takes 5 canals to produce what we have today. And even there, when water comes in from the north, it comes in 6 times faster than it can be moved south. So when we get into a flood situation like we do many rainy seasons, The only way to get rid of that water is east and west. But most of it is coming from north. Over 80% of the water is coming from north of the lake.
Gene, what is the condition of the water as it enters the Everglades National Park these days?
By law, any water entering the park must meet federal standards, which are 10 parts per billion. But if you look at the water coming from the north of the lake, it's often at 180 parts per billion. Some of that phosphorus settles out in the lake. When it hits the Everglades agricultural area, it's somewhere around 120 to 100 parts per billion. As it flows through the Everglades agricultural area, it's actually cleaned up. And as Mr. Ellis stated, you know, we reached a 68% reduction. So you take 100 parts per million, take 68% of that, and you're down to around, you know, 50 parts per billion. But then it has to go through the stormwater treatment areas to bring it down and cleanse it all the way to 10 parts per billion before you can put it in the Everglades.
Let's talk about some of the techniques you guys use to do your milling and refining. I know you use a lot of leftover plant fibers. Either one of you guys want to talk about that?
Yeah, so sugarcane is a very resilient crop, and we actually use every part of the cane when we bring it in. So the water that's brought in is used in our process. We use it to create steam. We actually use the leftover fiber, it's called bagasse, and we use that as our fuel for our mill and refinery. We produce enough power from the power we generate from sugarcane fiber to power up to about 25,000 homes a year. And that's a process that, you know, we do every year. We grow our own fuel, essentially. There's also some other uses for the sugarcane fiber. It's actually used as a compostable paper plate and takeaway containers that you'll see in stores. That's made from sugarcane fiber. It's biodegradable. It actually goes back into the ground about 90 days. You know, better alternative to some of the plastics and styrofoams.
Tell me about preserving the soil, Michael. How do you go about that?
Sure, there's common methods through the BMP program where, you know, one thing that we would create buffer zones between our canals and our fields where we let vegetation grow. So wind-blown soil stays on our property, doesn't get blown off our property. We'll grade it back to where, you know, it doesn't flow off our property. It flows back into our property. And then common practices of mucking out the canals. You know, and we build sumps in front of our pumps. So, you know, on a routine basis, we'll go in and we'll clean the canals, put that soil back on the field. So several practices to do that.
All right. If people have questions about U.S. sugar and farming in the Everglades, where can they go?
I would say the best thing, if you're local, is come out and see us. We have, hopefully, you know, once we get through this pandemic, we bring out about 8,000 people to Clewiston a year. You get to see it firsthand. You see our harvesting practices, get a tour through the mill. That's the best way if you are in Southwest Florida or South Florida. You can visit us on ussugar.com. We have a lot of this information on there.
All right. I'd say that was a kind of sweet panel, right? All right. Thank you, gentlemen. I appreciate it. Our live stream will resume at 10:30 Eastern. We're going to take a little break. We'll be speaking to two corporate leaders about innovations in plastics recycling. Stay with us as the Edison Awards Meet the Innovators Forum continues. For the folks here at Babcock Ranch, you folks on the stream, you can tune out if you want right now. Those of you who have signed up for midday field trips around the Babcock Ranch, buses will be ready for boarding in about 25 minutes or so, 10:30 departures. The food trucks catering our lunch will start serving at 11 a.m. in the lot just down the boardwalk to your left, and there's plenty of seating available on the terrace. You can break for lunch after or between the field trips. Now, if you have any questions about your field trip reservations, the folks at the registration table are happy to point you in the right direction. The afternoon sessions, enjoy your tours. It's spectacular. You're going to love it. When you see that solar array, you'll be blown away. Afternoon session kicks off at 1 p.m., and we look forward to seeing you back here as the Edison Awards Meet the Innovators Forum continues. Thank you very much.